Did you know your network setup could be costing you more money and time than it should? Imagine needing separate power cables for every IP camera, VoIP phone, or wireless access point. Clutter, extra costs, and frustration. But what if there was a way to power and connect devices with just one cable? Enter Power over Ethernet, PoE. This game-changing tech slashes costs, boosts reliability, and eliminates cable chaos. But wait, are you using the right PoE type? Stick around, because in this video, I'll reveal how to choose the best PoE solution and avoid costly mistakes. PoE, Power over Ethernet. PoE is a technology that we use to power devices through standard Ethernet network cables. It was invented when the first VoIP phones were deployed. The older version of the phones, those that are analog, are powered directly by the same copper wires used for voice calls. VoIP phones that use Ethernet cables without power must have a network adapter. Older analog phones only required one cable, while VoIP phones need two. This was seen as a technological regression. That's why PoE was invented. PoE really took off when it could also be used on wireless access points, which is a big advantage. Today, PoE is used for many devices. For example, on VoIP phones, IP cameras, wireless access points, as we have seen. We also have small routers and switches. And even the Raspberry Pi also works in PoE. All these PoE devices are simply called powered devices, PD. We will now see how it is possible to power an Ethernet cable. A device that provides power over the cable is called power sourcing equipment. This term is found under the initials PSE. To provide power, there are two options: the N-span and the mid-span. The N-pan PoE method uses a switch with built-in PoE. Typically, on Cisco switches, the ports that provide power are framed in yellow. When a device is connected to the switch, it will be detected automatically if it is PoE enabled. If so, then the power will be turned on. PoE switches come in a variety of sizes, and only certain ports may be PoE enabled. The other power method is the mid-span PoE method, which allows PoE technology to be added without having to replace your own non-PoE switches. They are smart devices, and, like a PoE switch, they also allow you to detect if the powered device, PD, needs power. This type of device is very useful if you have very little equipment to power. PoE injectors are useful when you only have a few devices to power. There are even small PoE injectors, which can be used to power only one device. So, is it better to use mid-span or N-span? With a mid-span solution, the disadvantage is that you have two devices to manage: the switch and the mid-span. You will therefore need to provide additional space in your rack. And what's more, the more devices you have to manage, the greater the risk of failure. The advantage of the mid-span is when you are equipped with recent switches and you do not want to replace them to benefit from PoE. Because if you had to replace all your switches to get PoE, well, this solution would necessarily be more expensive. On the other hand, N-pan PoE switches have a limited amount of power that they can provide. That is, you may not be able to use the max power on all ports on the switch. Cisco was the first company to introduce PoE in the 2000s. Basically, it was a proprietary technology, Cisco inline power, where Ethernet cables carried 48 volts, VDC, directional current volts, to power VoIP phones. Today, there are several PoE options. It ranges from proprietary to standard. The IEE being responsible for the creation of many 802.3 Ethernet standards, has also developed a standard for PoE. There are therefore several types of PoE based on IE standards. This is what we will detail. Type 1 is the first PoE 802.3 AF standard from 2003 that delivers up to 15.4 W of direct current to each device. It can be used with UTP Category 3 or 5 cables. This type is very useful for VoIP phones, dual radio wireless access points, and IP cameras, which do not have a motorized function. The second PoE standard, 802.3 AT, dates back to 2009 and is called PoE+. It can provide up to 25.5 W and requires a minimum Category 5 UTP cable. Type 2 is therefore useful for devices that require more power, such as motorized IP cameras, i.e. with PTZ, pan-tilt-zoom function, wireless access points with more than 3 radios, but also LCD monitors or tablets. Type 3 is UPoE, Universal Power over Ethernet, which is also called high-power PoE. For this, it uses all 4 pairs of wires and supports up to twice the power of Type 2. That is to say, it can go up to 60 W for each device. Very useful for powering small network switches, for example. And Type 4, which is based on the same standard as Type 3, the 802.3 BT standard, is called UPoE+, Universal Power over Ethernet Plus. It provides 100 power per port and also uses the 4 pairs of the cable. This allows it to be used for laptops or even for televisions. Before we finish the course, we'll describe the pros and cons of PoE. Let's start by looking at 4 benefits of using PoE. Savings. PoE saves money as there is no longer a need to install separate power supplies and electrical cables. Everything works on standard Ethernet cables. Reliability. PoE is very reliable because the power source usually comes from the technical room, which is usually secured by an inverter. This allows PoE-connected devices to remain powered, even in the event of a power cut. Security. In addition, PoE adds security as it has an intelligent power distribution, which helps protect equipment from voltage overloads or underpower. Flexibility. And we have great flexibility because it becomes very easy to move or reposition the devices without the need for an electrical cable. All you need is a network cable, and that's it. The main disadvantages of PoE are related to the production of energy and heat. We will therefore detail the 5 disadvantages of PoE. Heat production. We have a heat production because the increase in power increases the flow of current, which leads to an increase in heat in the cables of its network. Environmental heat load. We have a heat load on the environment. In the case, for example, of a high-power PoE deployment, this would increase the ambient temperature and would require increasing the air conditioning to regulate the temperature. Safety. There can also be an impact on safety, as excessive temperatures can cause the cable insulation to overheat and cause a failure on the device. Aging of the material. Another disadvantage is on the rapid aging of the material due to the high temperatures. Performance. And the last disadvantage is the performance of the Ethernet cables. Because the more there is heat and the more losses there can be inside the cable. This has the effect of reducing the maximum distance of the Ethernet cables. Without PoE, the maximum length of a Category 5 Ethernet cable is 100 meters. And depending on the type of cable and the amount of power, well, it's very likely that this distance can't be maintained.